In this project, we want to take in the AC main supply of 220 volts to light up these LEDs. So I have an idea. We just pick up these LEDs, widen its leads or terminals, and then plug it into the sockets, right? Wrong. LEDs only accept direct current. So in order to convert this AC to DC voltages, we are going to need a rectifier circuit. In this diagram, 220 volt AC mains is supplied to a transformer which steps it down to a lower voltage in the same AC, and then to a bridge rectifier diode circuit for rectification, and then to a capacitor for filtering, and finally to a regulator for further filtering and stepping down of the voltage to 5 volts as output. If you need a detailed explanation of an AC to DC converter, I have made a video for that in this channel. So you can click on the link attached to this video for that. Now back to our build. Let us list out all the components and items that we need in this project. We need a breadboard to build the circuit on, and a transformer with the following rating: 4 diodes, that is the 1N4001 diodes. Then we need capacitors of this rating. We're going to need 2 of these capacitors. Then a voltage regulator, 7805, the 7805 voltage regulator. LEDs, a 1 kilo ohms resistor, and finally some jumper wires for our connections. Now let's look at our transformer. This transformer has black wires for the primary side of the transformer and orange wires for the secondary side. The high voltage AC goes in through the black and then out through the orange color as stepped down AC still. Now I want to find a way to supply power to this transformer through its primary side, of course. Now I'm using this power cord. This power cord has 2 sides. One is the plug to take in the power supply and then pass it out through some sort of female connector here. You can see that, you can see the 2 holes. So I want to pick the lead of this transformer, that's the primary side, and then fit it into this hole so that I can get power supplied to the transformer through that. But before I do that, I will be using a multimeter to read the power source and see what value I have. I have just set the multimeter to read in AC. Now I'm plugging in the probes into these holes. I'm able to read the power supply as 179 volts. Now I want to supply this high voltage into the transformer by connecting the primary side of the transformer to the connector. I've done that already. And now I have my multimeter set up to read AC voltage. This is supposed to be a stepped down voltage, which is lower than the input voltage. So I'm setting the probes on the secondary wire. I've supplied 179 and I'm getting 9 volts. From the transformer rating, if I was to supply 220 volt, I'll be getting 12 volts. But here I'm getting 9 volts, which is enough for our project. So let's go back to the breadboard to build the second stage of this project, the bridge rectifier circuit. This is a network of 4 diodes. More attention is paid to the polarity of these diodes to build this successfully. Now I've picked up one of these diodes and I'm placing it on the breadboard, taking note of the polarity. This is the negative terminal of the diode as shown by the gray painting here. I've picked up the second diode and I'm connecting it with its terminal, with its negative terminal connected to the negative terminal of the first diode. They should be forming a right angle like this. As you can see, both the negative terminals of these 2 diodes have met at a right angle on the breadboard. I'll be doing the same thing for the remaining 2 diodes. I'm placing them exactly to form another angle at the opposite side of the first right angle, but this time around it's both the positive side, positive terminals that are meeting. So it means diagonally on the other side, I have my negative terminals meeting each other, and then the other side directly opposite on the diagonal, I have my positive sides meeting. Now we are done setting up the bridge. It's time to feed in the AC signal from our transformer. In order to do that, I'm going to need two jumper wires. Each should have both a female and male connector at its ends. So this is it. So I'm picking one of the female part of the connector and I'm connecting it with one of the secondary wire of the transformer. I'll do the same with the other one. This is it. So now I need to fit in these two wires into the bridge. The bridge has 4 junctions. There's a relationship between the two diagonally opposite junctions. Now let's take a look at one of these junctions. Look at it closely. You will see a negative terminal of the diode meeting with the positive terminal of the other diode. They are all meeting in a junction. This signifies the point where an AC can be fed in because the polarity is changing at that point. Now look at it diagonally opposite, you have the same thing. That is where the next wire of the AC signal is connected. The remaining 2 diagonally opposite junctions of the bridge is where our pulsating voltage would be tapped out. One of the terminals would only allow positive vibrations to pass and the other negative. Now how do you know which is which? Take a look at this junction very closely. We have 2 diodes meeting with their negative terminals at this junction. It means that the negative signal of the AC signal will be held back, only the positive part will be passed. The same thing happening at the diagonally opposite side of this bridge, where only the negative would pass out, forming the negative part of the DC signal. In this way, input AC power is rectified into output DC power. But the problem is DC output power consists of pulses and not pure DC. These pulses are also known as ripples. In order to take off this ripple, we need to purify this pulsating DC by using a capacitor. So I've placed the capacitor on the breadboard and I'm maintaining the polarity. I'm connecting the ground to the negative terminal of the capacitor and then the positive to the positive terminal of the capacitor. From here, I want to move on to the next stage of our AC to DC converter build. Now the next thing is to bring in a regulator, the regulator. Now the regulator will do some filtering also and then regulate the voltage to our intended output voltage, which is 5 volts. So we are using the 7805. Now look at the terminals closely. We have the first lead here is where the input is coming in. That's the first lead of the regulator is coming in, and then we have the ground in the middle and then the output, which is 5 volts. Now we are receiving signal from the capacitor terminal, the positive side, and then we are feeding it into the regulator. That's it. Then we will also tap out the negative from the negative part of the capacitor to the negative or the ground of the regulator. Now the last lead here is our output 5 volts. So I've just connected a jumper wire out of there. Now let me also extend the ground by using another jumper wire, so I can have 2 jumper wires dedicated to my pure DC voltage. Here now we have pure DC voltage. Now I want to let me put the leads in where I can see them clearly so that I can read my output voltage. I want to verify that I'm having pure DC of 5 volts. Yeah, so let me place this here. Okay, these are my output terminals, pure DC. So I'm setting my multimeter to read DC. Now I've just plugged in the AC input voltage. Now I want to read my output voltage. 4.95 volts, that is it. 4.95 volts. This is 5 volts DC, pure DC. So that's it. Now I want to connect a load to it. In this case we have our LED, but before doing that I want to add more capacitor of the same rating, that is 100 microfarad. I'm connecting it in parallel with the other capacitor. I'm maintaining the same polarity, nothing more. I just need more filtering. So now I want to connect the LED, but before then I'll be connecting a 1 kilo ohms resistor to limit the voltage so that it will not destroy my LED. Yes, so this is the LED. I'm connecting the positive side to the resistor and then the negative to the ground. So now I want to plug in my AC in. Yeah, that is it. So I have my AC going in at 220 and then it's lighting up the LED. That's it. So thank you for watching, and I hope you've learned something in this video. If you need more explanations regarding AC to DC converter in details, please check the video in my channel. I will try to connect the link with this video so you can go directly to watch and learn more about AC to DC converter with Pro Tools simulation. I also demonstrated different waveforms from AC to DC, talking about the change in the waveforms from the sinusoidal signals to direct DC signals. I illustrated that in one of my videos. So if you like what I'm doing, hit the like button, subscribe to my channel, and see you on the next one. Thank you. So let's make some analysis with respect to what we've just built. I want to read the input voltage going in as AC. So I've set my multimeter to read AC. So let me see the value of the AC going into the AC terminal of this bridge rectifier. Okay, 9 volts. Okay, the stepped down AC voltage is 9 volts going into the bridge rectifier. Now let me read the DC voltage. Let me read the DC voltage, the rectified DC voltage. I'm getting 11.4. Now, why is this 11.4? Why is the voltage stepped up? I'm expecting to read 9 volt at DC, right? But why is it stepped up? Let me explain that in a minute. The input voltage to the transformer is AC, but it is the RMS value, the same thing as the output voltage of the transformer, which is the step down RMS value as 9 volts. After the rectification, our meter is reading 11.4 volts. Now this is the peak value. Peak value is expressed as RMS times √2. Now our RMS value here is 9 volts. When you times that by √2, you will get 12.726 volts. Now this voltage is not still our measured voltage here as 11.4. So what happened? Let me express something here. The bridge rectified voltage that is filtered and captured by capacitor storage achieves the peak voltage of 1.414 times the AC RMS voltage of the secondary voltage minus the diode drop. Now at the bridge rectifier there are 2 diodes which their voltage drops will be subtracted here. Now the normal voltage drop is 0.7 for one diode, but we have 2 diodes which is 1.4. Now 1.4 will be subtracted, which will give us 11.32. Now 11.32 is approximately what we are getting from our meter reading, which is 11.4. Now this is how you got that reading there. And finally, for fun's sake, I just want to measure the voltage across this limiting resistor is 2.6 volts. Now this is the voltage that is lighting my LED.